Hello, Dimitrios. What was your first computer?
My first computer was an Amstrad CPC 484, and all my friends had Spectrums and Commodores at the time, and especially the Commodores had better games. But the good thing about it was that because there were not good games on the Amstrad, I learned BASIC. I learned BASIC and a little bit of assembly code, more or less. Yeah.
Okay, cool. I had both because I had an Amstrad, which was ZX Spectrum as well. I think Amstrad bought ZX Spectrum in one
At some point.
Yeah.
Well, yeah. Well, it was a very nice computer, very nice. I remember. Yeah.
Yeah. And what was your first, Hello World with BASIC? So what you wrote? So there was no Hello World, I suppose. So what was your first running program?
Well, I'm sure everyone did the same. So the first one was probably 10 print Dimitris, 20 go to 10.
Yeah, exactly.
Yeah.
and the next and the reasonable one. So you manage to implement a game or something like this?
I think my first, let's say, more real one was I wrote some sort of loader for games, and the loader, when it started loading, it could print on the screen Jimmy soft. Well, Jimmy, it's like one way to say Dimitris as well in English.
Okay.
And it will print out in the screen and put down a lightning and make a sound like, like an explosion, and then the game would load.
Cool.
And I would show this to my friends, more or less.
And they were impressed?
Yeah, very much.
Yeah, perfect.
As well.
Very cool. And you stick with BASIC, how long? Or what was your next language? I suppose assembly, right?
I did a bit of assembly. And then I went to study computers like sometime later. And then I went through all the languages of the time. So I did BASIC, Fortran, Pascal, DBase, Prolog, Quick Basic, the whole lot. Yeah, so a bit of everything.
Okay. And so what was your first reasonable program in another language? So after BASIC, you did what? Pascal?
I did Pascal. My favorite language back then was C.
Oh, really?
And I loved C because it was, the language itself was very small. Like the book of Kernighan Ritchie was like, I don't know, 50 pages, 100 pages. So, you felt you had full control of the language. You knew the language completely. Mm-hmm. Whereas later in my career, when I did C++, and I did C++ for quite some time, for 4 or 5 years, you never felt like, you really know the language completely. It was very complex. The standard library, it was a very complex language, very powerful, but complex. So I loved C back then, yeah.
But you still did the C on CPC Amstrad, or was it a different machine?
No. C, I did it on a like IBM compatible computer. It was a 286.
Oh, okay.
Yeah.
So it's interesting. So I had 8086 and then nothing, and then I jumped to Pentium. So it was interesting. So I skipped, all the 2, 3, 4, and then the next reasonable computer was Pentium. And where was it? Was it in Switzerland, or where you started hacking? And
No, that was all in Greece.
Ah, okay.
So I grew up in Greece, in Athens. So I went to university there.
Uh-huh.
And then I went to Ireland. I did let's say, master's, and I worked in a group that was doing mostly network programming, and it was great. It was a great experience because we did. I don't know if you remember. You remember ISO the ISO stack.
Yeah, this is the layer, right? The
Yes.
network layer. Yeah.
Yeah.
Like
But there was an implementation called ISO DE, ISO Development Environment, that implemented like the specs, the full specs for the layers above, TCP/IP. It was very, very complex. It was very complex, and I had to do some sort of gateways to map protocols on top of this huge stack to more reasonable protocols on top of TCP/IP. So it was something called ISO SR, search and retrieve protocols to search for bibliographic data. And that was mapped to Z39.50, which was the same thing layered on TCP/IP. And the cool thing was it was a lot of, network programming. So things that now we see like we call it, reactive. Well, we were doing reactive back in 1994. With different tools, of course, and different constructs, but all the things were the same. And what was very, very interesting was back then I worked on a European project together with some Danish guys, and it was the first time I saw beautiful code written in C, because most code was like really spaghetti, C++. But when those guys came into the project, I saw a different universe. One of the guys was a university dropout, who had written back then one of the most popular adventure games on the internet, text-based, enter a cave, look right, look left. It was one of those guys. And
was it Rogue?
I don't remember the name. I don't remember which one, but I remember there were like 2-3 popular ones, and he wrote one of them. And you could see, code that later on there was this language, Objective-C, developed, and it looked the constructs were very similar to the ones we were using. And just to give you an example, at some point we had to process bibliographic data, lots of them. So
sorry, what is bibliographic data? Is it like books or I don't know?
Yeah. You go to a library, and the way to record in a standard way the books, there used to be some standard, so we had to implement this standard and process records in this standard and do various things on them. And because there were lots and the processing would change, we thought, let's write a language, a DSL for processing bibliographic data. And with those guys, it was like a no-brainer. Yeah, sure, we will write a language to do this. Rather than do it manually in code, we will write a language to do this kind of processing. So with those guys, a whole lot of opportunities opened up with what you can do with programming, using standards, using open source. Everything we did was open source back then. And on top of that, they developed a business model around this. So they had, what we produced in this project was offered in a dual license, GPL, and then you had to, pay to get a proprietary license. So that was an open source business model back in 1994. The company is still there 25 years later, and it kind of gave me an initial idea of power of programming, open source, and standards, that I later came to see with JBoss, more or less.
And hopefully passion as well, right?
Yeah, definitely. We had such a good time. 2 years I worked with those guys. I loved it, and and then
which year was it?
1994, 95.
Wow. Okay, and the company is still around?
It's still around. You can look it up. It's called indexdata.dk.
Indexdata.dk. Interesting.
They're a small consultancy, like small. Now there are 20 people or something, but they still continue on that model. So they're super experts in what relates to libraries, automating libraries, and they're very good. And they're having fun after all those years writing C, C++. I think a little bit of Perl, basic stuff, but very, very powerful.
Okay, cool.
Yeah. So after that, I think I went to the Navy. You had to serve in Greece, and then I worked for telecoms.
And you enjoyed your time at Navy, or was it?
In the Navy? Well, there's an initial period which is fun, because you learn some stuff, you shoot with cannons and you work on radars, but the second part was very boring, although they took me to help in an IT facility. And in this one, they had a very old Bull mainframe, very old, yeah? And the people operating it, most of them, they were like clueless. So, so this is fun. They used us. We knew more than them, but anyway. So there was a guy, and his job was to essentially write a query in COBOL. They have asked him, for example, tell me how many boots are there in this facility. And he would write a program. There was no query language. He had to code it in COBOL. And he would give it to us, and we would run it overnight and print like 1.5 meters of paper, A3 paper. And then the guy would come the next day, look at the top of the stack, and go like, oh damn, I made a mistake. Do it again now. We were just, pushing paper left and right. It was horrible. And anyway, it was fun. And I also got to see one PDP-11 that was used as a simulator for some naval training. I got to access this machine for a week or something. So, anyway, interesting experience. Not the best way to spend your time, but, it's obligatory.
So in Germany, it was similar. It was like the first 3 months, it was more action. It was called like the, how it's called, base training. And after the 3 months, it was completely boring usually. So there nothing happened. So this was seems like European model,
Yeah. And then I worked on telecoms, and it was a very big project that we had to write code in C++ and Java. And what I did there was instead of writing like solving the problem, I started to create the tools to solve the problem. So essentially I developed a sort of an application server in C++. So it had like configuration, naming, threading, security, messaging, macro language to help you define, manage objects. So instead of solving like my own part of the problem, I developed the infrastructure for a team of 20 people to develop on my application server in C++ and CORBA. So then when I tried to...
And what was the concept? Like someone would develop, it was like more or less like EJBs or similar, or like servlet, something like that. So you wrote a class, and this class would be called by your server?
Right. It was like I offered you the base EJB functionality, and you wrote your EJBs, and immediately you got connected with the rest of the framework, and you got all those facilities for free that I mentioned.
Okay.
Configuration, naming, threading, yeah.
And you had to...
Of course,
you provided a source code, and it was compiled, or was somehow linked to your server?
Right, yeah. So basically, you wrote in C++, you had to inherit some of my classes and use some macros, and everything else would magically work. You became part of the framework.
Okay, cool.
And then I tried to do the same in Java.
Why? So that's the question. Why? How you bump to Java? So what is your first, when you saw the first time Java? Yeah. So why? When you first saw Java, when was it? And what was your opinion about that? This is the most interesting part, yeah?
Yeah. So imagine that was in 98, right?
Okay.
And in this project, we used C++ for the server and Java for the user interfaces, for the clients that would visualize those, this system. Yeah. So back then, I was not doing Java. I was doing the server side. For the next project, we had to build a service provisioning platform. And at that point, I was sure, I want to do it in Java because I felt it would be good enough performance-wise, and I wanted to learn Java as well. And I saw that there was a lot of stuff in Java already there compared to C++. So I thought there would be some reusability, some libraries I could use. That's why I started with it. And immediately I wanted to transfer this container in the Java world. So I started looking, what can I use? And I came across this technology called JMX. I'm sure you know about it.
Yeah.
And the funny thing was I didn't know anything about JMX. JMX was at the beginning. And I found it very interesting that a very large part of the code I wrote looked so much like JMX. We even used the same, let's say, function names. I didn't know about JMX, right?
Cool.
So it's funny how you come to the same conclusion from a different direction, right? So
one question, you like Java? So if you moved, from C++ to Java immediately, so you like the Java experience or not that much?
Initially, it felt a little bit constrained and weird and probably too verbose.
Yes.
Yeah. I didn't like that you didn't have multiple inheritance, no control of memory model. So some things I liked, some I didn't. Yeah.
I also moved from C++ to Java, and what I really wanted to have is this include H, the header files. I always search in Java for the header files, like how they are implemented without the header files. I mean, what are the header files? I was completely confused. So this was my experience with Java.
I think we must be around the same age, right? I'm born in 71.
Yeah, I'm 74. So
okay. All right.
Similar.
All right. So look, JMX, and then I'm trying to see who's using JMX, right? Just out of curiosity. And I came across this project called JBoss, which was using JMX. And JBoss back then essentially had the same idea I had in my own project, which is to use essentially an agent technology as the core for a framework. And why do that? Because that would give you a pluggability layer, and immediately what you do is manageable by definition, right? And I realized that the guys had the same idea. There was a guy called Richard Oberg.
Exactly.
Was a genius.
What he's doing right now, you know this?
I think he's somewhere in Asia.
Okay.
And he's doing, he has a company to develop software for, well, anyway, I met him in the summer at JCrit, so
okay.
I'll ask him again. Yeah. Anyway, so JBoss essentially took this idea of a dynamic kernel plus all the dynamic proxy functionality to give you this unique experience where, you put your EJBs in the deploy directory, and everything was generated at runtime without pre-compilation steps, with nothing. even all the CORBA stuff, everything was fully dynamic. And when I saw this, I got hooked up. I thought those guys are geniuses. So essentially, I took the early JBoss kernel, JBoss 2.
Mm-hmm. But this was later, right? Because the dynamic stuff came with JDK 1.3. And I think JBoss started before that, right?
JBoss started before that.
And they rewrote everything, as I remember. There was what was the Special Forces guy?
Marc Fleury.
Yeah, Marc Fleury started JBoss because he left or tried, to apply at BA. Mm-hmm. And then he said, okay, then I start my own server. And then I think it was rewritten by the yes. With GEMX. Uh-huh.
And that was version 2. That was version 2 to around the year 2001. So
you started with version 2, right? So you saw
I started with version 2, but to essentially take it, remove the things I didn't need, add my own stuff, and use it as the platform for my other project.
And what was the name of your project?
Well, initially we called it Junction, but then it was renamed to Action Streamer. It's still there. It's still there. It's used to activate services in telecom networks.
Oh, interesting. Action Streamer.
Yeah. Mm-hmm. Yeah. So the end result was that, okay, we're doing Action Streamer, but slowly the JBoss, let's say, volunteer work became more interesting than my day job. Mm-hmm. So we contributed some subsystems. We did the first SNMP agent in JBoss. And
your day job was telecom, right?
Telecoms, yes.
Yeah.
Telecoms.
Okay.
And at some point, it just I was going home and I was writing code for JBoss, and then when they got funding, they were able to hire the more active developers, and they made me an offer in 2004, and I went to work for them as core developer. So I worked there. After the fact, I found out that the reason they hired me was I was very strong with CORBA, and they were trying to certify JBoss for Java EE compliance, J2E, and they were very much stuck at the end of the certification. The end is the more difficult bit, because there was this functionality called CSIV2, which is really to allow calls between different application servers. So let's say an EJB in JBoss calls an EJB in WebSphere, right?
Oh, okay.
And they have to transfer transaction and security context between them. And the only way to do it is over CORBA, essentially. And a whole functionality was missing. So I went there and implemented this, and we managed to complete the certification, get the certification stamp. JBoss 4 was the first certified server, essentially. And then at some point I became a project lead, JBoss 4, JBoss 5. And traditionally every few years we change project leads to bring fresh ideas into the server. Jason Green took over the lead, and I became manager of the team. And I helped deliver the first product as Red Hat, so JBoss EAP. 4.2 was the first product of the application server in Red Hat. And up to recently, we went through all those phases, refactoring, Wildfly, and then EAP 7.2 was my last release. Mm-hmm. And now I more or less left the EAP team together with Jason and some other guys, and we're doing now Quarkus. Mm-hmm. And I'm also overseeing the Vertex team through Rodney Russ, another guy, and the Thorntail project. So what we call, let's say, cloud-native runtime frameworks, more or less.
Yeah, okay. It's actually interesting journey. One question regarding the CORBA. As I remember, the JBoss used JACORP back then, right? This is the CORBA ORP, right?
Yeah. Yeah.
And you helped that to integrate this, or?
When I joined, it was already integrated.
Mm-hmm.
Although for my own projects, I did other integrations as well. So I was also using OpenORB with JBoss and ZACORB. I extended the integration to allow this type of interop between different application servers. And well, the way CORBA was used in JBoss was brilliant, because all the CORBA objects were also dynamically generated when you deployed something, which was, never done in the industry before. So there's a paper on that on the internet. There was a Brazilian professor, Francisco Reverbel, who wrote this.
Mm-hmm.
And you can find it on the net. It's, it's just, internal details that for most of people, mean nothing. But for me, it was, it was just great technology. Yeah.
Yeah. Send me please the link. I will put it to show notes about the paper.
Oh,
right. My opinion about CORBA is I use also CORBA a lot, and of course it was a little bit chatty. So you had to first to get the reference to the, I think it was called naming service, and then provide some lookup, and then there was portable object narrow. So you had to narrow, so cast the object, because CORBA was multi-language. But after the 3 lines of code, it was just remote procedure call. I mean, there was it just worked. And what I always wondered myself is why they don't modernize, the bootstrap. So I would say you could just, hide everything behind let's say an object, and just make it injectable, because then this would be a nice replacement of gRPC and Apache Thrift. I mean, whatever was invented after CORBA was exactly the same idea as CORBA. So I always wondered myself, why they just reinventing things and not modernize a little bit the API? You had the same thoughts, or why is that? Because if you take a look at gRPC or Thrift, they have the same story. They have the IDL, they generated the stubs and skeletons. So I really don't see the difference.
Yeah, well, I think it's stupid, to be honest. I loved CORBA, and especially the binary network format, I think was very efficient. Mm-hmm. And I think we took steps back when we moved away from this. The programming model was not the best, but you have to consider that it had to work in different languages.
Exactly.
Not just, now, what happened with CORBA really is EJBs. When EJBs came, they became ubiquitous, and that was the end of it. CORBA was only used for cases where you had to interop with different languages, right? Mm-hmm. So I don't, if you've been long enough, you see this happening over and over again. We discovered technology, we rediscovered it in a different format. I remember back then, the early application servers had the servlet and the EJB layer separate, right?
Exactly.
And then JBoss came and said, "Oh, look, this is stupid. You put in the same VM and it's 100 times faster."
Yeah.
And then we got microservices, right? And then it's split again, and it's a lot slower. So many projects that don't really need microservices, but because it's hype, everyone wants to do it. So we're going back and forth.
And the cool story is, last week I had actual discussion about microservices, and they told me what we really would like to have, have 2 microservices talking to each other, which are completely type safe. So they generated stubs and skeletons with for REST and JSON. So I then asked them, so why you're not using SOAP then? I mean, SOAP did it for years, and if you don't care about the protocol, and the next question is, if this is type safe, if you change the server, you will also have to change the client. So why you have microservices at all? Just put everything to one JVM. And they looked at me and said, actually, this is a good idea. We actually probably don't need microservices in this project. So yeah, probably not. This is Really, it is really, really strange because it's like developers have the internal need right now, to just create microservices to create microservices. And it was exactly the same back then. So what I remember is EJB containers and web containers had to be split to increase scalability. I say, look, why exactly you are increasing scalability? Because, EJBs do usually nothing, and servlets do nothing, and the database do everything. So the more, you scale in the front end, the more trouble you get, in the back end.
Right.
Yeah.
Exactly.
But what we could do right now, back to IOP, it would be technically possible, to make, let's say, a simple Java interface injectable. This interface, we can just generate, let's say CDI. So we can create an interceptor which generates on the fly the IOP protocol and talks CORBA to other services, right? This should be possible.
Well, you could do it. Just that, just saying the word CORBA, it turns off many people. So you have a hard time find followers. Yeah.
Yeah, this is marketing problem, but I mean the IOP protocol is efficient, and there are already bindings in different languages. So I mean, yeah.
Yeah. Well,
we could rename it, to like Nano protocol or whatever. So
sure. Yeah. Yeah. So yeah. So Quarkus now. Quarkus is the thing.
Quarkus. You said Quarkus.
Yes.
What struck me is the following. At the beginning, Wildfly tried to do everything at runtime. And what Quarkus tried to achieve is to do everything at build time, right?
Yeah, it's the exact opposite.
Exact opposite.
Very much, yeah. Which, well, it depends on the use case. The use case here is to minimize the outcome.
Yes.
So we want smaller executables, less memory, faster.
Mm-hmm.
So that's the way to do it, really. Yeah.
Now, question: how you heard about Quarkus, or have you initiated the Quarkus project? So how it started? So, I mean, yeah. How was it?
Well, I'll give you my own view, right? So, so in Wildfly EAP, every few years we look at the next generation. And we had lots of discussions what next generation Wildfly might look like, whether it will be the same, different architecture, compatible or not. And we were doing this in conjunction with the Wildfly Swarm and Thorntail team. And we had discussions. The guys wanted to go the Thorntail before direction. We thought we could go another direction, and then we had a meeting together, and we thought, let's try to work together and see if we can come up with a unified architecture. And so that was mostly between Jason Green and Bob McWhirter. And then Manuel also came independently from another direction, saying, "Oh yeah, maybe it's a good idea to have one runtime for everything." So all the guys came together, which is not very common in Red Hat. In Red Hat normally every team did their own thing. So for once we said, okay, let's try to prototype something that could act as as one base runtime for everything, and see how far we can get with that. And that was a prototyping effort, like 3-4 months that went on. We set some goals, and of course we looked at different technologies. And like the one technology that looked very interesting was the substrate VM, because substrate was very strong at producing optimized native, code. So the team more or less looked at, how best to enable substrate, and they came up with this architecture that really moves as much as possible at build time, so as to produce the most optimized artifacts for substrate to kick in and do its job. And at that point, when we saw that, we could do Hibernate, and Hibernate is like one of the most difficult cases, very dynamic, very hard framework. So when Hibernate worked, then we felt good, and the team felt that, now we can do anything, basically. Mm-hmm. And then the project really kicked off. And it was supposed to be a secret project in Red Hat for some time, and then the team grew. I came in as like engineering manager of the team, and then we made it public in March. Mm-hmm. So something like that. So really, I think Quarkus was the collective result of some of our key people thinking on the problem for some time. We had different efforts before Quarkus as well to come up with a very slim runtime and things like that. But it was the first time that many people came together, and it was an interdisciplinary effort. So we have people from kernel design, performance, Hibernate, Wildfly, Thorntail, Vertex, collaborating, and we got this beautiful result. I think it's really beautiful, and if you look at how we do it internally, mm-hmm. It's quite different from anything else that was out there. Some people thought, you copied Micronaut, but it's not true. It's a very different architecture.
When the effort started, when was the initial meeting with Jason Green, you, and Bob?
I think that was in spring, the year before.
Not bad. So it was actually pretty fast.
No, it was pretty fast. Yeah, it was pretty fast. Mm-hmm. Yeah.
And everyone from Red Hat told me, we are working on something and you will like it. It's like, okay, I heard it so many times before, I don't believe it. And I don't know whether you know, but I got lots of questions about the Thorntail and Wildfly Swarm. And I look at that and I would say, okay, it's a little bit more efficient than Wildfly, but it's really not worth, the effort. And what I really didn't like at all was the whole branding, like, right size your services or whatever. It's like, why? I never had that issue, with the size. I mean, Wildfly is just small enough. And then I look at the Quarkus, and what I really like at Quarkus, it is more like the Java E, deployment model, and everything with Java. What I like about Java E pushed even further. So it's not and in a very consequent way. And it makes everything even leaner, which makes absolute sense. And the almost collateral outcome is everything is smaller. So to give you an example, what I really like is, for instance, the idea is genius. I was really interested who came up with the idea, but the deployment of a war to application server doesn't make a lot of sense because it doesn't have to be dynamic. This is what you found out, right? If you deploy a war, the application server have, to scan a folder, have to parse the XML files and generate proxies or whatever. And what Quarkus does the same, but it does it at build time. And therefore, you can remove from the server the whole deployment machinery and the parsing machinery and make the server thinner. And now what's really great, I get the deployment errors at build time. So for me as developer, there is even, a added value. So I don't have to wait until deployment time. I see, the errors at build time, which is win-win situation. So it was actually never before. So this is why I really like at Quarkus. It's like, it's not like trying to introduce, different runtime because Java is no more fashionable. It's more like, can we go even further and make it even more efficient? And this is what I really like. The very first time a framework which I see this is really interesting.
Yeah. Well, it's even more important if you say this, right? We totally respect your, the way you approach things. And like 2 comments there. One comment is Quarkus in one sense looks very much like, Java microprofile, right?
Mm-hmm.
So a standard microprofile app would probably run without any changes.
Mm-hmm.
So that's very familiar. You can have code that has 0 imports, like of our own frameworks, for
mm-hmm.
example. So that I think that's the power of standards. And then the interesting thing was that, although this effort started to trying to optimize Java for native, the, let's say, unexpected outcome was that we improved very much Java for standard hotspots, because exactly we do all this work at build time and we come up with what would be essentially, what's the sequence to start up your objects and wire them together.
Mm-hmm.
This is the starting point. And this makes the code very fast, very lean, very less memory hungry on standard hotspots. So, you would expect your normal Java app on hotspots to be like taking half of the space in memory
mm-hmm.
and booting like one-fifth of the time. And we talk about speed, boot speed, memory size, but there's also big improvement at runtime. There was a blog entry like 2 days ago. If you go on the Quarkus side, we published some benchmarks that show how much we have took, we carefully tuned the stack to perform at runtime. So you will actually see a runtime improvement, performance improvement, both in native mode and hotspot mode. So it's a win-win.
What's also interesting in Quarkus, it was actually a funny story. So I think 2 years ago, I recorded an online course. It was about testing Java EE. And what I also did, I explain how to stress test or load test applications and how to measure the performance. And it's like, okay, what use case can I take? And what I did, I compared the performance of CDI and EJBs. And EJBs were 20% faster because they were pooled and the dependency injection happened only once. And someone from IBM took this, Sam Olisov is his name, and created a GitHub a project and make it more formal. And also said, okay, this is really true. EJBs are faster. And on Quarkus, it is no more the case. So this is the interesting part. So of course, there are no EJBs at Quarkus, but what happens on Quarkus is the dependency injection happens at code generation at build time. So at runtime, there is no overhead. So I think even this was solved, accidentally by Quarkus. So we could just go, with request scope or whatever. And this is not like we use dynamic proxy, which gets injected over and over again, rather than the code is already there. And there will be probably, if we had EJBs on Quarkus, I think there would be, the performance would be very, very similar to CDI.
Right. Yeah. No, you're right. Yeah. All those are results of this build time optimization.
And who came up with the idea to do everything at build time? This is interesting, actually. It was.
Well, I cannot tell.
Or was it obvious that you have that you all have to do everything at build time, or just accidental idea? This is what's more interesting. Was it clear to all of you?
Again, for example, I'll tell you, like in Wildfly, we had ideas to do stuff at build time, essentially, like pre-compute the deployment model, or
Okay.
Yeah. So yeah,
you had the ideas before. I have to admit, as if I saw it, I said, this is genius, and I completely overlooked that. I completely overlooked the possibility that the deployment could happen at build time.
Yeah.
So I never saw this. This was actually, for me, it was striking. This was actually a cool experience. And what I also like is the how to call it, the build time extension model. So I created an extension for Wildfly just for fun, and they were like the build steps. And to create a simple extensions, you only have to expose the classes you are using, and then they are taken. So at least it worked for me. And you could also communicate between extensions. So you can say my extension needs the another extension. But this is very, I would say, no XML configuration, or there's just, annotation-based programming model for extensions.
No, I think the extension model is quite nice. We can make it a little bit more user-friendly. And it will really be, I think, a key for the next step of Quarkus. So basically to produce extensions, either, written by Red Hat or by the community for the most popular use cases. And the good thing about the extension is, you write it like once, and then everyone gets benefit. And a well-written extension will more or less completely hide the fact whether you end up with a native, image or a hotspot, let's say, image. So yeah, we would like to see more uptake from the community in that. And then other typical things we expose in Quarkus is the dev modes. I think it's very nice. You get this very fast iteration. Server starting immediately, you see the changes. So
for the audience, you only have to do maven Quarkus :dev and it runs.
Right. Yeah, and it's the people faces when they first see that you change something, refresh it there, and it's Java. It's not JavaScript or anything.
But this is not the killer. I expected something like this. It's okay. Everyone tries to do that, but what's really cool, and this is not is your fetch jars are not fetch jars. This is what I did. I wanted to immediately see, what is the outcome of the build, and what you are doing. You are creating a runner jar, and I say, okay, again. So if I change, one class as, let's say, a servlet, I will have to rebuild the whole Quarkus and push 20 megs to the clouds. And then I say, I took a look at the size of the jar, and this is like 90K. It's actually impossible to have, 90K, everything in there. So I open the jar, and there is a manifest. Look at the manifest, and it just points to libs. And in the lib folder, you had, I would say, 40 different jars, and they are from more or less Wildfly projects, which is very good because, Wildfly is bulletproof, so there is no need to reinvent your own servlet engine or whatever. But the point is, what you can do right now is, to put all the libs into base Docker container and just push your business logic, the jar, to the clouds over and over again. And because Docker optimizes the layers, I get exactly the same benefits what I got, with my ThinWar approach, where I push the server once and then 50 times a day I just push the ThinWar. So even this works as expected. So you didn't even try to create an Uber jar or fetch jar. You created, you have the split from the beginning, which was impressive to me because everyone else tries to, create Uber jars or fetch jars, and I never got the idea why they are doing this.
Yeah, I mean, it doesn't offer any benefit to, just rebundle and unbundle all the time. And, it just doesn't make sense. So
No.
And it's completely opaque, with Docker containers, layering. It doesn't matter, It's less efficient, so sure.
And the next cool feature is you have to. These are the really killer features. If you use GraalVM on my machine, so you can do maven clean install -p native, and Quarkus will generate a native executable application. But this is no Mac or Windows version or Linux version. But the cool story is you are providing a Docker container which is called something native, docker.native, I think. And what this does is it will build a native image inside the container, which is portable. So then you get, a tiny Docker container, which is based on Fedora and contains internally the native image. And this is also genius because now you create, the native image once and you can launch it in whatever environment you like.
Right, yeah. This
is the killer features. Everyone is excited about the dev mode. It's okay, dev mode. I never had a problem, with redeployment times. But these are the small things which are genius in my eyes.
Yeah, and I think we spend a lot of time thinking about how to do things, and whenever we need to add something, there's a very big discussion between the guys. As a manager of the team, I'm very much humbled by the brain power and the different skill set that people bring into the project from their own point of view, right? Because in Wildfly, we were excellent, framework writers, but we didn't have like Hibernate expertise. That was a different team. So now it's all the teams are together. There are people from all teams that contribute to the different ideas, and I think we're more careful introducing any change, because a project can easily get fat quickly,
Yeah.
if you just add stuff without much thinking. Yeah. Now another change we're doing is, we in Quarkus we want to offer both imperative and reactive APIs for the most common use cases, but to truly optimize this experience, we are refactoring the core so that it's unified. So imagine you have a netty layer, and on top of it you have a vertex layer. So there's vertex at the core, and on top of it you have like undertow, for example. So the full stack, uses the same base, let's say, abstractions, and the different subsystems can communicate very efficiently with each other. So we're very careful to do it right, so it's slim and performant and seamless. So we will, some things might take more time than we wanted, but we hope that the result will be, better in the long term. Now, most people don't see that, right? They just, they don't care about this, but they will care when they see the, performance. And people don't maybe realize, but with Vertex at core, we can gain advantage of the full, let's say, ecosystem of Vertex clients, all those reactive clients that are developed through the years. So in one regard, Quarkus is new, all the built magic, but a lot of the stuff is very mature, actually. It's like projects that have been out for years, and they're used and optimized and stuff. So
what you can do, you can just go to the lib folder where Quarkus creates and tail ls minus al, and you will see all the libraries, and they are mostly well-known libraries from Wildfly. It's not like complete reinvention.
Yeah. And have you tried the Panache API?
I tried that, and I like that, but this is a little bit out of scope of my commercial projects, because usually this is JPA, and so my clients would not migrate to Panache. But if we would start, with a startup, this could be something different. We could try Panache, but the danger is here. It is not JPA compliant. So let's say if Quarkus dies,
sure,
which is of course unlikely, but it could happen, then you are stuck with Panache. And so far, what I like in Quarkus, it is, as you said, which actually a few weeks ago, just for fun, a client asked me, we did a proof of concept and we ported an older microservice, even with legacy DB2 drivers, to Quarkus, and it worked out of the box. So we were all amazed actually that it works. So I spent probably 2 hours. So it's not like multi-day effort. It's just we just migrated EJBs to CDI, and this was not like huge effort. We did it iteratively, and then it just booted and it worked. And with Panache, it's a little bit different. But I like that. I'm a little bit careful, don't leave the path of microprofiler in Java, because then you are stuck with Quarkus, which was never a good idea before.
Yeah.
But Panache could become microprofile, microprofile spec.
I totally understand that, and it's just the intention is to try stuff. If it makes sense, we push it to the standards. JPA was born out of Hibernate, right?
Yeah, exactly.
So yeah, we will definitely do that. And personally, having worked on standards like almost all my professional career, like 20 years now, I know very well how difficult it can be. And in some cases, it feels as if, you have to go to a boxing match, right?
Yeah.
With one hand tied behind your back, and have the guy on the other side just, giving you punches, and you cannot do anything with this, So I'm sure you get the idea, but with Quarkus, we will try to be, let's say, as much standard-based as it makes sense, but at the same time, we will try to be more innovative in some dimensions to try to push the standards even further out.
Yeah, because what I did immediately, I created my own archetype called Quarky. It does nothing but, it uses Quarkus and adds all the dependencies I need all the time. It's like all the small rise dependencies and scheduler and ORM Hibernate. So it feels and looks like a Java E server. And this is important to me that I can just, not all of my clients have, Quarkus or Red Hat. Some have Open Liberty. Lots of people are using Payara. So I cannot just go, Quarkus full. But right now, what I like about that, I can use, Quarky as almost drop in replacement of Open Liberty or Payara. And I can still add more extensions like Panache if you would like to, to experiment with it. So it's not like I'm stuck with something completely funky.
Right. Yeah.
And regarding standards, in the back, what my impression was, this is always the case with JCP. My impression was that most of the vendors are building the Hibernate was first, then JPA came. This was the story of JPA, or MQ series were first, and then JMS happened, and Oracle was first, then JDBC happened. It's not like someone tries, in JCP innovate in vacuum. It's more or less the developers like to code, and then they write, the spec afterwards. This was at least my impression.
Yeah, exactly. I mean, you need some successful implementations before standardizing. Otherwise, you do, I don't know, CMP.
Yeah.
EJB CMP, yeah.
Yeah, and the interesting story with CMP was, at the same time at Sun, there was another project. It was called, I think, Javelin, and this was like, I think it was Javelin. It was like very like JDO, so it looked already like JPA, and for unknown reasons, the CMP took off. So, but there were two projects at Sun. One was already very like JPA, and the other one was CMP. So it was just, the wrong approach was taken.
Yeah. Yeah, well, yeah. And standards, they're challenged now. The situation with Jakarta. Microprofile is doing better, and we will keep pushing there for sure. But, time is of essence, and we've lost lots of time in Java.
Microprofile is perfect, and I mean Jakarta is stable enough, so it could be used as the base and microprofile as innovation, and then everyone should be happy. This would be my personal, approach. Yeah. Mm-hmm. A small thing, what would be cool in Quarkus is I write a lot of command line tools actually with Java, and it would be really nice if Quarkus could be used as command line tools. So I would pass command line parameters and just run CDI or whatever, and just will have my own, native image, which will launch whatever I like.
Mm-hmm. Well, definitely, and another very interesting use case similar to that is using Quarkus to write operators, in
Kubernetes.
Mm-hmm. And there was a first one written just recently, and we really feel, like whatever, 10 million programmers, Java programmers, now have a better chance to just carry their, knowledge into this brave new cloud native world without having to relearn everything. So, I'm very positive about this. Now, if we're missing some, facility like to help you write base CLIs or anything like that, we would gladly accept, pull requests.
Okay.
There's a lot of work, there's a lot of work for, but we would need help, and community contributions are always welcome, basically. Yeah.
Okay, perfect. So where people can find you on the internet, Quarkus you, and give me some coordinates, Uris.
Yeah, well, for me the easiest way, it's Twitter, Dandriadis. Now I'm mostly tweeting about Quarkus, Quarkus.io, the project. Sometimes I blog, blogspot, again, dandriadis.blogspot.com. So online you'll find me. I go to some conferences that are like not very far, but I'm mostly spending my time with the team and trying to make this a successful project / product.
We are try to be more efficient with our time. By the way, I think we never met in person, right?
I tell you what, we met one time in the Netherlands, where there was an event, I don't know, at some company, and we went there to present something like, I think, we went
Java E5, and this was like the water tower or something, right? This was like...
Yeah, that was it. And I remember you told me, why you don't offer support for Wildfly community project?
Yeah, it should the ERP should be more synchronized with the Wildfly. Exactly. Yeah. Perfect. And then I know you.
Right.
Yeah, perfect. So thank you, and I would really like to invite you again in few weeks or month.
Yeah, why not? If we have news from Quarkus, what the team is working on, I'll gladly, come.
Perfect. So greetings to the developers, to Emmanuel and all the others.
Sure, yeah.
Okay, thank you and bye.
Thanks, bye-bye.